Okay, this is going to be lesson 2 on limits for pre-calculus. We're going to move into actually the physical calculation, not by graphs, by just looking at the function. So where I want to start is this concept of how limits and continuity and sort of how they go hand in hand. All right. Now, one thing I want you to understand is any polynomial, x to the 4th, x to the 3rd, x squared, x to the 6th, x to the 7th, these are always going to be continuous. And since they are always going to be continuous, for all continuous functions, we sort of talked about this with the chart, whatever you evaluate, all right, whatever they're trying to get, whatever that number is also going to equal the limit. Okay, we'll go over that in a second. All right, there are 3 types of discontinuity. All right, you have you have removable discontinuity. That's like our whole, where we can eliminate these things. All right, that way. All right, you have infinite discontinuity. That's when you have an asymptote. Okay, all right. Now some examples of those. Then you have a jump discontinuity, okay? Jump discontinuity is when I substitute for a number at this point. That first one would be 7, that second one would be 2. So we got, this is off, so that's a jump, okay? All right, so there's discontinuity. Now, somebody's gonna ask, Mr. Evans, if it's always continuous, then you're gonna get a limit. Will you get a limit for these different continuities? And the answer is, for removable, okay, you will, all right? For a removable one, you will. You will get one, all right? For an infinite, sometimes you're going to get one, okay? All right, and for a jump, all right, if it's at that point, it matters. So to sort of answer that question, all right, it depends on some factors, all right? It depends on factors, all right? Let me see what my next page is here. All right, couple of the factors it is determined by, okay? So for things that are for discontinuity, okay? The first thing that it determines, okay, is the limit as x approaches that number. Is that number the discontinuity? Okay, so sometimes we see things that could be that have discontinuity in it, but is that number a part of the discontinuity? For instance, even in the jump example, and we'll do some of these in a second, is if the limit is not if the limit is not trying to approach, okay. Sorry, hold on one second. Okay, if the thing is not approaching the discontinuity, that's a part. Okay. You know, is that if it's not part of the discontinuity? All right. Is it in a continuous part? Okay. So sometimes the examples, okay, all right, you know, we'll try to say, well, that it's discontinuous at that point, okay, all right. Well, that really depends upon what that number is in the limit, okay. One thing you always want to do, another note, all right, always try to factor and eliminate, okay. That oftentimes will also help you figure out your discontinuity, okay? So let's start with some examples, okay? Let's start with some examples. And what we want to do is we want to look at these examples and ask ourselves, if it's continuous, I'm good, all right? So if I look at this, all right, this is a continuous function. So how do I find this answer? All I'm going to do is I am going to evaluate that number at 3. Okay, because whatever that result is, evaluated is that limit. Okay, because this is always a continuous function. All right, 3rd minus 5 to the 3rd squared. Okay, and that answer is just going to be 9. Okay, And that's, all right, what it equals. And just to show you that, if I went to a table and just surrounded that point, okay? Let's say I put in 2x cubed minus 5x squared, getting back to something we've done. If I put in, let's say, 2.99, that's really close to what? 9. Now what if I put in 3.001? What is that really close to? 9. So instead of having to do that every time, I can just know that if it's continuous, that will work out. Okay? Now, let's look at this one. A limit, all right? Anytime I see a fraction there, I'm thinking that could be an asymptote. So when I look at this, all right, that number would be part of the discontinuity. All right? So, how do I check this? All right? How do I check that? Once again, if I'm looking at that discontinuity, I'm going to evaluate that slightly bigger than 4 and slightly less than 4. All right? So what I would do is I would evaluate that limit at 4 from the plus side. Okay? So what that would be from a calculation standpoint, I would do like 4.001 plus 2 divided by 4.001 minus 4. All right, what do I get? Big 6,001. Okay? All right? Now I would do it at the limit as x approaches 4 from the negative side. Okay? So I got 3.999 plus 2 divided by 3.999 minus 4. And I get a negative 5,999. Now, as you can see, those are two totally different parts. So this one would be does not exist. Okay, because I'm not getting the same thing for that. In that case, would be that asymptote. Okay, let's go ahead and look at this one. All right, before I examine this, let's go ahead and factor that part. That part would be x minus 2, x minus 1. This part would be x plus 2, x minus 2. Okay, now what happens is I have eliminated that. So what I can really do is I got x minus 2 over x plus 2. Okay, this x approaches 2 is not part of the discontinuity. So I can just go ahead and evaluate that. So that's going to be 2 minus 1 over 2 plus 2. Because that 2 is not part of the discontinuity anymore. Okay, all right, so what I can do is 2 minus 1 is 1. 2 plus 2 is 4. So 1 divided by 4 is 1/4. So that would be what my limit equaled. Okay? Because 2 is not part of the discontinuity anymore. It's gone. It got eliminated in there. There's still a hole in the graph, but it actually does have a limit. Okay? Of 1/4. Now let's look at this one. All right? Once again, this eliminates. Okay? All right, so what I got is 2x plus 1 over x minus 3. Now I'm doing it as x approaches 5, so once again, it doesn't matter because it's not part of the discontinuity. So all I would do is just evaluate that. All right, 2 times 5 minus 1 divided by 5 minus 3. So that answer is 4.5. That's what the limit would equal there. Once again, is there a hole in the graph? Yes. Is there still a limit? Yes. And that's what we're seeing graphically and analytically. Now, let's look at these. As x approaches negative 3. Okay. Now, this looks like this could be a jump discontinuity. But what I have to do is I'm going to calculate that at 3 from the negative side, and I'm going to calculate that from negative 3 on the positive side. Okay? All right? So where's negative 3? I know my board space is horrendous right now. All right, this is negative 3 from the negative side. So I'm looking at like negative 3.001. Okay, that would be in here. All right, so if I evaluate that thing that should actually be a line underneath of it. Okay, if I evaluate that thing at less than that, so negative 3.001, all right, plus 3, all right, that gets me to about 0. Okay, so that's about 0 for this, okay? And then I do, for this other part, I would use this function. Why? Because that would be on that side, okay? So I got, I would get, like this would be negative 2.999, all right? So negative 2.999, okay, squared okay, minus 9. That's also very close to 0. So this actually has an answer. This is 0. Okay? All right, now, let's look at the limit as x approaches 1. So what I got to do is look at the limit as x approaches 1 from the negative side and the limit as x approaches 1 from the positive side. All right? From the negative side, I would do that, okay? Because that's approaching from the left. All right, so I would do like 999 squared minus 9. Okay, it's negative 8, okay? So this would be like negative 8. Now for the other one, it's slightly bigger than 1, so I would do like 1.001 plus 6, because I would now be using this answer, and that's 7. So that's two different ones, so this is do not exist, all right? So always check those both sides of the limits if they're continuous, all right, or the discontinuity is in doubt, okay? All right, so what I like you guys to do, so as this goes, is I like you to do these problems, okay? So this one is automatically going to be continuous, so I can just go ahead and evaluate that at 3, so 5, 3 cubed plus 1. So this answer of the limit would be 136. Okay, now let's look at this one. All right, this is potentially bad because this asymptote, that would be a point of discontinuity. So what I have to do is check the limit as x approaches negative 5 from the negative side and the limit as x approaches negative 5 from the positive side. All right, so what I would do is evaluate that at 2. I would put like negative 5.001 plus 5. Okay, I get negative 2,000. All right, then I would do 2 divided by, let's say, negative 4.99 plus 5. That's going to be positive 2,000. So as you can see, there's a gap there. So this is a do not exist. Okay, all right, this next one, okay, I would factor be 2x. I think it's going to be x plus 4, x minus 1. This bottom part will be x plus 1, x plus 4. All right, now, I do have a hole here for this, but this is going to eliminate. And now this negative 4 has no relative nature in the discontinuity, so I am good there. So I can do 2 times negative 4, all right, minus 1 times divided by, all right, negative 4 plus 1. So I get 3 for an answer there. That is going to be my limit, okay? So you just got to watch, is that point part of the discontinuity? All right, now this one, I factor to x plus 6 and x minus 5. This is x plus 6. This eliminates, so I'm left with x minus 5. All right, now, once again, is this part of the thing? It is not at all. I can just go ahead and put negative 6 in there. Negative 6 minus 5 would be negative 11, okay? And that's how I get that answer, okay? Now let's go this one. Limit as x approaches 0, okay? So at 0, all right, this is going to be pretty easy. I just have 5 there, all right? So even if I do the limit as x approaches 0 from the negative and the limit as x approaches 0 from the positive, okay? All right, what would I have here? All right, so if I go from 0 negative, that would be less than, that would be this, so this would just be 5, okay? Limit as 0 approaches from that side, that would now be that side, so 0 squared plus 2 is 2. So this is 2 different answers, so this is a do not exist, okay? The limit as x approaches 3, okay? So what I got there is I would want to do 3 from the negative direction and 3 from the positive direction. Well, 3 from the negative direction is going to be this one. Okay, so I would want to do like 2.99 squared. Okay, all right. I should have done 0.1 back there. It still would have not existed. All right, so 2.99 squared. All right, plus 2. Oops, what happened here? Oh, that's weird. Oh, squared plus 2. So this one would be about 11. okay? And then 3 from this side would be like 3.001 plus 8. That's going to be 11 also. So this limit is 11, okay? So sometimes those piecewise functions are continuous and sometimes they're not. I mean, have limits and sometimes they don't, okay? All right, now, you got to be also mindful of these square root functions, okay? So with the square root functions, you have to watch, okay? Remember, all right, square roots, okay? What we have to do with the inside part of that square root, the idea is it's only possible the domain at greater than or equal to that. So we got to be careful because the only x's I can use are these ones that are greater than or equal to 3. So what you have to watch is the limit, you have to check how the limit is involved in the domain. If it's well into it, you're fine. If it's at it, okay, if it's at it or less than it, you got to check, okay, for your limit, okay? If it's in the domain, if it's in bigger, you can just evaluate. Okay, so at 3, this is a problem here. Okay, so the problem is when I put 2.99 in for this. Okay, because I got to check each way. 2.99 minus 3. All right, look what it tells me. It even tells me it doesn't have it, so this does not exist. Okay, so this answer is does not exist. Okay, now this one I would have to worry about x being anything less than -2, but this is okay. This is well into it. Okay, so I can just go ahead and evaluate that at 2 plus 2 squared root 2 plus 2 is 4, which would give me a result of 2. Once again, I can use that because in the end, that's well into the domain. Okay, let's look at this one. All right, this one I'd have to worry about if x was greater, the domain is x is greater than or equal to -9. Now, once again, the 7 is fine. That's well into that. So I can just do 7 plus 9, which is the square root of 16, which is 4. Okay, now this one, if I go to find the domain on this one, I would set that equal to 0. It's got to be greater than or equal to 0. So the idea is x would have to be greater than or equal to 10. Well, this is a real problem because 8 is not greater than or equal to 10. And what happens is, even when I choose either side, what happens? Oh, wait, I need to put that in parentheses. 8.001 minus 10. I got that, it didn't even exist, so this is a do not exist problem. So you got to be careful about the square roots. All right, sometimes they're not going to have limits, and other times they are. It all depends upon, is the number that they're asking for in the limit, is it okay in the domain? If it's well into the domain, you're good. If it's at the domain or less than the domain, you're probably not going to have a limit for that, okay? All right, so what I'd like you to do is go ahead and pause your video and go ahead and work on these, okay? This one, all right, greater than or equal to -5. That's well into that, so I'm just going to go ahead and evaluate that. That's square root of 9, which is 3. That's the limit for that, okay? This one, set that equal, the domain is this, subtract. All right, the thing's got to be greater than or equal to -16. 0 is well into that. So I would just do 0 plus 16, which is 16. That would be 4. Okay, this one, I would set this equal or greater than or equal to 0, add 4. I got x is greater than or equal to 4. Now this is a problem, okay, because I'm right at that point, okay? And the problem is if I take 3.99, all right, 3.99, and subtract 4. That's an error. So this one's a do not exist. This one I would set equal, greater than or equal to 0, add 5. All right, the problem here is this is not near it. So if I put that in there, that's going to be a do not exist. Okay, why? Because 3 minus 5 is -2. Can't have a square root of a -2. Okay, all right, so I just want to touch on the square roots because I felt like those were important. Okay, now let's talk about some other problems. Once again, you got to look at, does the number get involved in the discontinuity? So we got a couple of discontinuities here. We got to have something greater than or equal to 2. We also have to have something that can't equal 4. Why? Because I solved that. That's a possible asymptote. Well, that could be a problem here. Okay, so we got to test that. So we got to do 4 from the negative side, 4 from the positive side. Okay, now I'm going to go ahead. I do parentheses, square root. Okay, 4 from the negative side would be like 3.99. Let me use parentheses inside that square root. All right, 3.99 minus 2, double close, divided by 3.999. All right, minus 4. Okay, that's a negative 1,400. Okay, it's a negative 1,400, 13, negative 1413. Okay, if I try 4.001, so parentheses, square root 4.001. I keep making that mistake. 0, 1, minus 2, close them again, divided by 4.001 minus 4. Okay, as you can see, I got a positive version of that. So this is bad. This is a do not exist. Okay, now let's look at this one. I got a possibility of an issue at my domain has got to be x is greater than negative 6. Okay, but I can't have a number equaling negative 3. Now, once again, this isn't an issue here, and it's well inside the domain here, so I can just evaluate this straight up. Okay, so that's square root of 9 over 6. That's 3 over 6, which is 1/2. That has one because 3 is not part of the discontinuity. Okay, now let's look at this one. All right, I got to have something x is greater than or equal to 1. Okay, I can't have anything that's negative 6. Okay, now the 1 might be an issue, so I got to try some stuff here. Okay, now if I do 0.99 minus 1, I think you know what's going to happen here. That's an error. So that's a do not exist. Okay, because you get no value on that. Okay, now look at this one. This one wouldn't be good. X can't be negative 1. Okay, now I don't have an issue there because 5 is not that value. So I can just do 5 minus 2 over 5 plus 1. That's 3 over 6, which is also 1/2. Okay, that's not an issue. Okay, look at this one. What could be a potential issue here? Okay, well, this could not equal 0 here, but the problem is there's nothing really that's going to be an issue. So I got 3, 0 squared plus 1, so that's 3 over 1, which is 3. That's okay. The 0 is fine there. All right, now let's look at this one. The limit as x approaches 3. All right, so like on the surface, this looks like it's an issue because, all right, if I'm at 3, but think about this. 3 is only going to be in here. So when I do 3.001 and 2.999, I'm going to be in this same area. So I don't have to worry about the discontinuity. Okay, so I got 2.999 plus 6 is about 9, and then 3.001 plus 6, it's about 9. So this answer is 9. Okay, why? Because that 3 was well inside. So you really have to monitor, where is the limit approaching? Is it part of the discontinuity or not? Okay, I think this is the last page. Yep. So I'd like you to pause your video and go ahead and answer these. Okay. All right. So this one, I got to have something greater than or equal to negative 2, but I can't have something equaling 2. All right. That's a problem there. Okay. So if I check the limit, negative 0.799, that's not going to be the issue. What's going to be the issue is the negative 0.081. Why? When I take that square root, forgetting about the bottom part, all right, I got 8.001 plus 8. Watch what happens. I get that error. So this one's a do not exist. Okay, I have this one. I got an issue with x. I'm fine if x is greater than or equal to negative 2. I can't have x being 7. Okay, this is a problem. All right, and let me show you why. If I put in 6.999, and 7.001, okay? Surrounding that, all right? So I got square root 6.999 plus 2, all right? Okay, divided by, all right, 6.999, all right, minus 7. I get negative 2,900. Okay, now if I use 7, all right, 7.001, let me use parentheses, plus 2 divided by 7.001 minus 7, that's going to be a positive result. So this is also a do not exist. Okay? All right, this one, I would only have issues. I want something where x is greater than or equal to negative 24, but I can't have something being negative 4. Well, it's approaching 1, well inside that, not that. So I can just go ahead and evaluate that. So that's square root of 25 over 5, which would be 5 over 5, which would just be an answer of 1. Okay, it's not a problem. Okay, now, this one would be 6. Once again, I would only have to worry about stuff that can't equal 4. So this is fine. I can just evaluate this because this will be continuous at this function. So that's going to be 3 times 6 plus 5 divided by 6 minus 4, which would be 11.5. That would be the limit for that. Okay. Now this one, all right, I only have issues at basically this would be, if I factored that, the x plus 3, x plus 2, x minus 2. Once again, the only issues I would have are at negative 2 and 2. But I'm having an issue at 3. That's not a problem. Okay, so 3 plus 3 would be 6 over 3 plus 2 would be 5, and then that would be 1. Okay, so 6 divided by 5 times 1 would just be 1.2. Okay, the limit as x approaches 0. Once again, the 0 is well inside this part of the function. Okay, it's continuous there. And even if I were to try that at negative, let's say parentheses negative 0.001 squared plus 3, okay, it's about 3. All right, and then positive 0.001 squared plus 3, it's also 3. So my limit here is 3. Once again, because that's really inside of there, it's continuous. The only thing you have to worry about is the jump area there. So that is some analytical stuff. The big thing is looking at what is the limit approaching. Is it approaching a potential point of discontinuity? If it's not, you're good. Okay? If it's approaching something where you know it is, you can evaluate it. If it's a point of discontinuity, you're going to have to check it and evaluate it.